the biggest challenge of designing a propulsion system is making sure we're hitting all of the highest performance standards. And so we're pushing the performance as hard as we can. Our customers are doing the same, but then the customers and us expect the reliability to be there as well.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 385. What's it take to build the most efficient and reliable UAS propulsion system? For that question, we head to Philadelphia to speak with Jon Broome, CEO and co-founder of Vertiq. Vertiq makes ultra-compact, high-performance servo motors for drone propulsion. Combining a unique hardware design and proprietary motor calibration and control software, Vertiq optimizes motor performance and controllability. As a result, Vertiq's products significantly increase the effectiveness of commercial and defense drones. UAS vehicles using Vertiq technology fly 10% longer, maneuver and stabilize 4 times faster, experience 75% fewer critical failures, and have access to unique propeller positioning capabilities. The company spun out of the University of Pennsylvania's robotics lab with the goal of perfecting the components that make vehicles move. Vertiq's mission is to bring high-end motor performance to vital robotic applications, starting with drones and in the future, expanding into ground and marine mobile robotic applications. In this episode of the Drone Radio Show, Jon talks about Vertiq, its revolutionary propulsion systems, and how such systems are changing the drone industry. But before we hear from Jon, I want to thank those of you who have been supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. Now let's learn about high-performance industrial-grade UAS motors with Jon Broome of Vertiq. Let's pick up the interview where I asked Jon to introduce himself.
I'm Jon Broome. I'm the co-founder and CEO of Vertiq. I started the company almost 6 years ago now with my co-founder, Matt. He got his PhD at the University of Pennsylvania, and I joined up with him to start the company way back in 2017. My background was kind of completely out of left field. I was an econ major who was just interested in entrepreneurship. And I went to Matt's PhD thesis defense and found the technology that he was developing at Penn to be really impressive. And he needed someone that was more business oriented to start the company with him. So he and I got together, and now fast forward 6 years, here we are with a team of 14 people bringing some pretty cool tech to the drone industry.
Jon, tell us about Vertiq. What does the company do?
Yeah, so our mission is to provide industrial-grade propulsion systems for drones and eventually other mobile robots. The industry right now has a bit of an issue where it's using very much hobby-grade propulsion tech. So these sensorless motors and controllers are known to be unreliable and underperform. And we're bringing kind of the industrial machinery, industrial-grade tech to these propulsion systems. And that's really our mission, is to make these vehicles perform better and make them way more reliable.
Before I go too far into our conversation, I want to make sure I have the correct terminology for the engines. What do you call them?
We call them motor modules. And really what they are servo motors. And a servo motor is an integrated motor, controller, and position sensor. And so most drone motors right now are just the motor and separate controller. What we do differently is we incorporate this position sensor into the design. And that's something that high-end industrial machines use. They use servo motors, but those servo motors are usually really bulky, really heavy. They're very high performance, but they're just not good for aerial vehicles because they're too heavy and too big to lug all that weight around. So we've designed a servo motor that is in the right kind of size and mass for aerial vehicles. And with that position sensor, you can do a lot of really interesting motor calibration and motor control techniques to make the motor perform a lot better. And yeah, so, you can make it more efficient, more powerful, smoother, quieter. You get a much greater degree of control and responsiveness out of your propulsion system. And we can also build in a lot of unique safety features to make the vehicle itself way more reliable.
What have you been able to achieve over other designs?
Efficiency is a big one that many drone companies point to. You want to fly as long as possible. So the way you drive the motor very basically is you're applying electricity at the right time throughout the motor's rotation to make it spin as well as possible. And if you're able to apply that electricity more accurately throughout the rotation, you can eke greater performance out of it. So for us, we're about 10% more efficient kind of across the RPM range compared to standard sensorless motors and controllers. And that's just one of the advantages. I'm happy to go into kind of all the other ones, but also don't want to bore the audience with the nitty-gritty details.
What are the benefits of Vertiq motors over other systems?
So efficiency is definitely one. Number two is controllability. So we have a closed loop control system. So we're able to respond 2 to 4 times faster than these other control solutions. And that means you can stabilize or maneuver your vehicle a lot faster. So that's particularly advantageous when you're navigating through a complex environment or you're fighting harsh weather conditions, stuff like that will allow your vehicle to stay on task or stay in the air as long as possible. So that's one. The size is also something that's really important. So the way we design the motor is to integrate the motor controller and sensor into a very tight package. And in doing that, we're able to reduce the mass of the solution by about 15%. And now that might not seem like a lot, but for customers that are delivering packages or want to strap on an extra sensor, for their payload, that's really important. They can collect more data, carry bigger packages, anything like that, just because we're reducing the size of the propulsion system. Or they can decide not to add anything and just fly a little bit longer because their vehicle weighs less. And then probably the most transformative benefit of our technology is the safety features. So in the factory, when we're making these, we have a calibration process that uses the position sensor to map various parameters of the motor. And we store that map on the controller as the motor's spinning. So that map we use to compare to its actual performance. So if we start to find that its actual performance is deviating from the map that was originally generated, that probably means something's wrong, and we can alert the operator to land the vehicle. So that's the stuff we're doing with the position sensor. It allows us to do all these very cool performance and safety features.
What type of drone are these motors best suited for?
So it's mostly for commercial and defense companies who have higher value vehicles that are doing really important tasks. So we are a bit more expensive than your typical system. So it's not something that a typical hobbyist would use, although we do make them available for anyone to purchase. So usually drones that are selling for $10,000 or more is our sweet spot for customers because they can usually stomach the extra increase in price. But what's really important to them is making sure their vehicle stays in the air as long as possible, whether that means, greater efficiency or reducing the number of critical failures, because their end users are using them for really important tasks. It can be inspection of important assets or search and rescue or agricultural, spraying drone. And if those go down, that's a big investment that they've lost. So yeah, it's really high value vehicles.
Do your customers typically buy the motors and put them on their drones? Or are there components or customizations that have to be made first?
You touched on a really interesting part of our business. One of the challenges that we face is pretty much every drone company has a slightly different spec for what they want their propulsion system to do. And that makes it challenging to create the exact product that's right for everybody. So what we've done with our motor modules is made them slightly modular so that our customers can use the base motor, understand the performance, but then add on certain, we call them add-ons, to tailor it to exactly what they need. So for example, for FAA compliance, a lot of customers need LED lights on the end of the arms of the drone, so that they can be seen while flying. We've created a simple add-on to our motor controller that you can just put a separate circuit board with an LED light on it and integrate that seamlessly into the motor and motor controller package. We can also increase the IP rating of the motor through attachments and a bunch of other stuff like that. So the modularity of our systems makes them well suited for any particular customer.
You mentioned earlier that users are able to monitor the performance of each motor in real time. How does that occur?
So typically what will happen is the drone company will identify what are the important things that they want to see from the motor. A basic example is, how hot is my motor getting? And we've created a model to essentially allow the motor to push itself to the point where, it will be performing as well as possible without overheating and causing damage to the motor. But if it does get to that point, we can automate it so that the operator can know, okay, my motor's getting too hot. Maybe you ease off throttle, or maybe you're flying in extreme conditions and you just need to land the vehicle so that, the motor won't continue to overheat.
What are some of the things that can typically go wrong with a motor while in flight?
Let's see. So we've had plenty of examples of motor failures, but that's a good thing. It's allowed us to push the technology forward. I would say the biggest symptom is overheating. And that can mean something is caught in the motor coils. It can mean the operator is pushing the vehicle very, very hard. It could mean you ran into an obstacle and you're trying to recover from that, or the drone is off balanced. There are a number of ways the propulsion system can be overtasked and overheat as a result. So I would say that's the most common thing that we find. But the reasons for that vary a lot, and it mostly comes down to environmental conditions.
What is it about the motor that makes the propulsion system so good?
The reason that we can do all of these advanced control techniques, make the motor more efficient and more reliable, is a result of this position sensor. If you know the position of the motor at any given time, you can apply electricity at the right time to make it spin well. And you can also understand various properties of the motor to a much greater extent than you can with the sensorless system. So all of our advanced features come from the fact that we have this position sensor and a tight pairing between the motor and the controller.
So each motor has its own position sensor.
Correct. Yeah. So these position sensors are unique. They're used mainly in automotive for a gas pedal, for example, and they're very small and very lightweight. Most drone people will be familiar with an ST microcontroller. It's what's used certainly on our motor controllers, but on other parts of the vehicle as well. And that position sensor is not much bigger than that component. So it's very, very small. And also what we do is we put a magnet in the shaft of the motor, and the sensor, the chip, sits right underneath that magnet. So as the motor is spinning, that magnet is spinning in the motor, and the sensor is picking up the magnetic field of the sensor to tell us the position of the motor. So that's how we get that, highly precise position information.
Don't other motors have position sensors?
They do have other types of sensors on it. They don't have the magnetic rotary encoder that we use. So they're not getting direct position information from their sensors. Mostly what they're doing is measuring current, so they're current sensors, and then estimating the position of the motor based on what they're getting from those current sensors. And those estimations, they're good. They make the motors work, but they're not as efficient as, what we do.
Can you elaborate on the position of the motors? What are we actually talking about in terms of motor position?
Yeah, it's the angular position of the motor. So as it's spinning throughout its rotation, we know the exact angle at any position. So we have to kind of set a zero angle and then go based on that as the motor's spinning.
What are some of the challenges in designing a state-of-the-art propulsion system?
Yeah, the biggest challenge is that all of our customers are pushing their vehicles to the absolute limits. The industry itself is relatively young and growing very quickly. And there are a few kind of established players and then a bunch of very hungry, smaller players that are vying for a market share. And to do that, they have to push their vehicles really, really hard. And a lot of that burden falls on the propulsion system. So the biggest challenge of designing a propulsion system is making sure we're hitting all of the highest performance standards. And honestly, we're one of those smaller fish that are vying for its position too. So we need to exceed what's currently out there. And so we're pushing the performance as hard as we can. Our customers are doing the same, but then the customers and us expect the reliability to be there as well. So I think in most kind of established industries, there's a general engineering practice of having a factor of safety where you make sure that the components you're speccing in are twice as good as what they actually have to be. Whereas in this industry, everybody's trying to get as much as they can out of the components. And so it's a blessing and a curse. It's a blessing because it's forcing us to make the product as good as possible, and it's making the industry itself progress very quickly. And the curse is that, you're going to have failures, whether it's the propulsion system or another part of the system every now and then, kind of in the name of research and development and pushing the industry forward.
Is there an industry standard or expectation for engine performance and safety? I mean, how does one know that the motors are achieving a certain level of reliability?
Yeah, right now it's very much relative to the competition and what people are currently used to. So there are no common safety standards or regulatory considerations at the moment for specifically the motors and the controllers. So what we do is we match up and compare against our biggest competitors, the big players in the sensorless motor and controller, the sensorless motors and controller providers. And that's quite easy to do for kind of motor performance. And then the reliability side of things, it's kind of on a case-by-case basis where we work with our customers to establish a certain standard, demonstrate that we can hit that. And if we aren't hitting that, what software features can we implement to make sure that their vehicle is protected? And that's one great thing about us is one of our divisions of the company is just focus on the software and firmware that make these propulsion systems run. And that's something that the industry doesn't have a lot of overall expertise in. Most drone companies don't have people that can dive into the motor controller code and figure out what's going on. So we essentially act as the propulsion team for companies and develop those standards with them.
What happens after the sale and delivery of the product to your customers?
We have someone who's appointed to each customer. Usually it starts with our sales team, and then we bring them into the engineering team to make sure that they have a point of contact on both sides. And one of the things that differentiates us from our competitors, who are mostly companies in China that are selling these sensorless systems, we respond as quickly as possible and as thoroughly as possible. And we have a team that's small enough right now that we can pretty much get anybody from, our lowest level test engineers to the CTO on the line to solve customer problems.
What is it about propulsion systems that excites you?
I think it's the potential of the motors that gets me excited. Like every single time we talk to a new customer, they ask for some specific control feature. And just because we drive the motor with this position sensor, we can almost certainly do it. And the most rewarding part of the job is to see our motors and controllers on customer vehicles doing important tasks. So that's what gets me excited. It's just, we've already developed a very solid product that's making headway in the industry and increasing the performance and reliability of vehicles, but it's also, what more can we do? And that's what's exciting for our engineering team and for me, kind of growing the business and thinking about, okay, how can we further differentiate ourselves?
I'd like to go back to the company's beginnings. First, how did you get involved in the drone industry?
Yeah, so I got involved through Matt Piccoli, my co-founder. He also happens to be my cousin. So there was a family connection there. I've now spent way more time with him as a co-founder than I ever did as a cousin. So that's a fun dynamic. He was finishing up his PhD right as I was finishing up undergrad at our respective schools. And I attended his thesis defense. At the time, I really didn't even know too much. I knew he was working on aerial vehicles, but I didn't realize he was kind of in the weeds of the motor and motor control. And he presented his findings, his thesis defense in front of us. And he had already talked to me about potentially starting a company based on his research. And that thesis defense was when I really got to learn a lot more about what he was working on. So yeah, after that, he obviously received his PhD and I was looking for work opportunity. So we teamed up to start the company in early 2017. And that's kind of the origins of my story. But the origins of the technology start with Matt. He was a PhD when the industry hadn't quite decided on the quad rotor as kind of the end all be all. Now, of course, there are many different vehicle designs, but he was working on making the most simple, mechanically simple vehicle possible. And so what that meant for him was, how do I reduce the number of motors and propellers on the vehicle while still making a functional flying thing? So what he was able to do was he worked with a fellow PhD student and they paired his motor and controller with the fellow PhD student's propeller to make a system which they called the underactuated propulsion system, which essentially allows you to have a drone with just one or two motors instead of your typical four. So he was working on these very strange drones, which were cool in principle, but in practice, they didn't have, at the time, too many applications. So, he decided to start this company around the motor and motor control, which has applications for normal drones and these unique, innovative drones.
Was there some sort of aha moment that led to starting the business?
I'd say we were pretty naive entering into the venture together. Both of us knew the technology was very interesting, and I knew that Matt was incredibly smart. And that's really what I was going on. So then the key was, okay, like we have this cool technology. What is the actual market for it? And how can we grow the business? And when you start a company, for first-time entrepreneurs, it's hard to know exactly where to start. So I think we were kind of throwing darts at a wall and seeing what hit at first. And, fortunately, within the first 6 months, we were accepted into an accelerator program that took us to China for 4 months, called the HAX Accelerator Program. That was our first really big milestone because that's a well-known accelerator program. In China, we got introduced to the hardware manufacturing ecosystem, and that was very helpful for the business. And we got a little bit of seed funding too, or accelerator funding. So that was great. We could justify our production run. We could pay ourselves a little bit. And it was kind of a great way to end that first year. And then after that program, we had to really figure out the business model. And for about a year, our business model was, can we license our software to companies, help them design the motors and controllers, and then kind of be hands off and let customers just license our software? And that business model, it was okay for a couple companies, and we closed a few customers with that model. But what became very clear going forward was most companies, they just want to buy a thing that works and integrate it into their system. They don't want to have to figure out the manufacturing for the motor, the controller. They don't want to manage the logistics and everything that goes into essentially creating a product. So that really forced us to sell the full product. We realized that companies they're willing to pay a premium for just buying something that works rather than licensing software, which they're pretty much not willing to pay anything for.
How did you fund the startup of the company and the early years of operation?
We bootstrapped it first, and then we got accepted into the accelerator, which gave us just a little bit of money so that we could survive kind of for year two. And in the middle of year two, we closed our first kind of big customer, and they're still our biggest customer today, Flyability. They're a fantastic Swiss company that makes an indoor drone that's designed to inspect really important but hard to get to assets. So we closed them, and that gave us some money to keep going. And we finally got to the point at about the second year where we realized that the technology is very scalable. We had mastered kind of some of the main pain points that we had in the early days from a hardware and software perspective. And so at that point, we were prepared to raise a round of funding. So in 2019, we raised a round of 1.2 million. And then pretty recently, we closed a round that was just under 3 million.
Where are the motors manufactured?
So right now, we manufacture overseas in China. We manufacture the controllers in multiple places. So some customers require us to do it in the US, and we can do it there. But otherwise, we'll do that in China as well because it's a bit cheaper. There certainly is pressure to move away from Chinese manufacturing. So we are exploring options for customers that need non-Chinese goods, but we have very good partners over there too. So it's a bit of a balance, but right now, yeah, definitely mostly overseas.
Did the decision to manufacture in China grow out of those initial contacts from the accelerator?
The contact mostly came from contacts within the drone industry, not from the accelerator itself, but the accelerator took us very close to that manufacturer. So we were able to visit and get to know them, which was very beneficial.
What have the past 5 years taught you about the drone industry?
It's definitely taught me that there are kind of endless possibilities for what the technology can do and how useful it can be for society generally. I tend to take a pretty optimistic view of where the industry is going to go and make sure that these drones are used for kind of good rather than for evil. And I'm sure some members of the government and public disagree with that, but I've just been really impressed with pretty much all of our customers, what they're doing, the different niches they're finding in the industry. And there's a huge market for a bunch of small niches, which is fantastic. So yeah, I'm just excited, fast forward 5 years, I'm excited for these drones to be kind of more present in daily life. Right now, they're kind of behind closed doors for big, commercial and defense companies, but they're going to be really useful for everyday use.
What advice would you give to other entrepreneurs?
Well, for first-time entrepreneurs like us, I would just say that the perseverance and talking to really knowledgeable advisors is the most important thing you can do. I've gotten conflicting advice from really smart people and tried both out and eventually came to the conclusion myself. So it's just a balance of, leaning on other people's experience while also valuing your own intuition. And yeah, for a hardware company, one thing that I wish we had done a little bit differently was raise money a little bit earlier and expand the team, but also have more of a focus on the market that you're going after. It's better, in my opinion, to be a big fish in a little bit smaller of a market than try to take the shotgun approach and try to address a bunch of industry's problems all at once when you're just a pretty small team.
What's next for Vertiq?
First things first is to finalize our SUAS product line. So we are focused on drones that are sub 55 pounds for our initial products. And there's about 6 motors that we need to release to get there, 2 of which are already fully commercialized, 2 are in alpha prototyping, and then the other 2 are in beta prototyping. So by the end of this year, we will have that line fully built out, which is really exciting because, now we can work with every SUAS company under the sun, and that's great. And then from there, we're seeing more and more larger drones being produced, for agricultural purposes, all the way up to the crewed aircraft. And so our goal is to start building these bigger motors and, more powerful controllers to pair with them in time. And then the long-term vision is to bring this technology to other mobile robotic fields. Really, if you boil down our advantage, we are the highest performance and most reliable motor in as small a package as possible. And that will be beneficial for aerial vehicles, ground vehicles, underwater vehicles. So our long-term vision is to eventually expand into those once we've really mastered the aerial market.
I would imagine there's a market for reliable, high-efficient, commercial-grade engines for urban air mobility vehicles. Is that a fair assumption?
Yeah, absolutely. They, more than even the SUAS, need reliable propulsion systems. The challenge of being a small company doing that is it requires a lot of upfront capital to prototype and test all of those products. But we're getting to a point now where we have the revenue from the SUAS products. We have good investor backing. So expansion into the larger drones is definitely on the near horizon. And we'd likely want to line up a few, 1 or 2 launch partners to do that with, just so that we know we have the market tells us that it's a good thing to do, but also specific customers that are willing to test out the product, because that customer feedback is valuable as anything.
Is there anything that we miss that we should talk about?
The one thing that we've taken advantage of over the course of our company history is the National Science Foundation and the Department of Defense SBIR programs. It's a great way for small companies to get some initial funding. And so I think that's important to bring up, because if there are aspiring entrepreneurs or even existing companies that just want additional R&D capital, it's a great way to do it. We found that it's a bit of a lottery system, though. You have to apply 2 or 3 times before you're going to get it. So it might take a year or two to get some free money from the government to fund R&D, but it's worth it when you do get it.
And for my final question, Jon, what message would you like to leave regarding the future of the drone industry?
I'm very optimistic for the industry as a whole. I think generally speaking, every company and every component company needs to work to make the vehicles as reliable as possible, to make the government and general public as confident in this technology as possible. And I think that's what we strive for at Vertiq, and a lot of our customers are doing the same. So I'm excited for the day when, everybody's kind of convinced that these small drones are as reliable as commercial airlines.
That's it for episode 385 of the Drone Radio Show. I hope you enjoyed hearing from Jon Broome of Vertiq. I want to thank Jon for taking the time to speak with me. If you want to learn more about Vertiq or want to connect with Jon, check out the webpage at vertiq.co, and Vertiq is spelled Vertiq. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.